Greetings, mentors. I'm Devansh, and I, along with my teammate Rishikesh, have prepared our project on image sharpening using knowledge distillation. I'll be briefing you about the same. We use Mimo unit as our teacher model, though it is designed for motion deblur. If trained on appropriate dataset, it performs equally well on synthetic blur cases. This is our student model, simple CNN with 5 layers, 64 channels. For the images, we decided to choose upon div 2K dataset. Since the images are in 2K resolution, we first crop them, then add blur using bicubic interpolation, as you can see here. For the training dataset, we are using patches of 256 pixels instead of 128 pixels for more spatial context. And similarly, for test and validation dataset, we first crop the image, then generate the blur using bicubic interpolation. This is our training script. We first load the teacher model, the student model, the data loaders, and here we generate the outputs. After performing some normalization, we have the losses and the loss function. Loss LP IPS is basically VGG for perceptual loss, loss GT, the ground truth loss, KD, distillation loss, and finally SSIM. Unlike PSNR, SSIM can also be used as a loss function. After every two epochs, we perform the validation and save the best model. Let me run the script for you. And it runs for quite some time, and after running, I'll have the output something like this. So as you can see, for 20 epochs, it took around 97 minutes. Best uh, SSIM it reached was 0.9326. This is the teacher model, and as you can see, it gives an SSIM of around almost 0.95. Next, this script is only for evaluating the teacher, how well does it perform. Finally, we have our testing script. So firstly, we can ignore this function. This is all to suppress some warnings. Coming to the main function, in order to have faster inference, we load our model using TensorRT. Then we firstly warm up our GPU, perform our inference, and save the images in results. Let me run the test script. So our inference ended, and as you can see, evaluation on 100 images and an average SSIM of 0.93. And for the FPS, you can see the pure inference FPS is 61 frames per second. We have the script to visualize the feature maps that are generated. I took a sample image and it will give the feature maps for it. Five layers, the parameter count. So these are the feature maps for different layers at different channels. Let's look at some of the results. At top, we have our ground truth, bottom left is the blurred image, and bottom right is the student output. Let's zoom in. So, as you can see visually, the blurred image, when compared to the sharpened image, the student output is quite blurry. The area around the texture around the eyes is not very defined, whereas in our output, it's quite defined. It closely resembles the ground truth image. Let's look at one last image. So as you can see, unlike our student output, the person here is not very well defined. Our student model does a good job in deblurring this image. Thank you.